This video will cover an important application of linear programming for making investments. This investment example here can be broken up to first write the objective function and then go into writing the constraints. So our first step is to understand the objective function. So the goal here is to maximize return by spreading the $100,000 of initial capital into 4 distinct investments. And the options available to us are bonds, mutual funds, stocks, or a savings account which yields interest. Therefore, our decision variables will be the amount of money put into each of the 4 investment options. So let x1 be the dollars put into bonds, x2, that will be the dollars put into mutual funds, x3, the dollars put into stocks, and x4, the amount of money put into the savings account. Now we can write the objective function which maximizes our total return. Each individual investment's return can be found by taking the return rate of the investment and multiplying the money put into the investment. So, for example, the bonds have a 3% annual return rate, and we invest x1 dollars into the bonds. So the total return for the bonds would be 3% times x1. And in decimal form, that would be 0.03 x1. Repeating this for each investment, the objective function will maximize the total return, which I'll label as z. So we maximize z, and this will contain all the returns for the individual investments. So starting with the bonds, we calculated it above. It's 0.03 times x1. Then the mutual funds give an 8% return, so that's going to be 0.08 times x2, the amount of money we put into the mutual funds. Continuing, we have a 10% return on stocks, so that's 0.1 times x3, the amount put into the stocks. And the savings account gives a 2% return rate, so it's 0.02 times x4, the amount we put into the savings account. This objective function is subject to some constraints, which is going to be the next step to building out this linear programming model for investment. Moving on to the constraints, we have 5 conditions which try to balance out the risk in our portfolio. The first condition is to restrict the amount invested in stocks, since they're a more risky option. The amount invested in stocks can be no more than 15% of the total investment. And the amount in stocks is represented by x3. And the total investment is represented by x1 plus x2 plus x3 plus x4, since the investment can be spread across all 4 of the options. So our constraint is that x3 has to be less than or equal to, since it's no more than 15% can be put into stocks, it's got to be less than or equal to 15% of the total investment. And so that's our first constraint. The second condition is to emphasize that 40% of the investment has to be in mutual funds and the savings account. So those 2 quantities are represented by x2 plus x4. And this has to be at least so that's greater than or equal to 40% of the total investment. So that's going to be 0.4 times x1 plus x2 plus x3 plus x4. That's our second constraint. The next condition is to limit the amount put into the savings account, which happens to be one of our safer options available. And so the savings account amount cannot be more than the amount put into the other investments combined. So the amount put into the savings account, that's going to be x4, and it cannot be more than, so it's got to be less than or equal to the amount put into the other investments combined. So the other investments are the bonds, the mutual funds, or the stocks. So that would be x1 plus x2 plus x3. That's our third constraint. The fourth condition is to leverage risk by putting more money into bonds and mutual funds, which are considered moderately safe investments. The bonds and mutual funds total is going to be x1 plus x2, and the stocks and savings account amount is going to be x3 plus x4. Now we want the ratio of these two values to be at least 1.2 to 1. So what I'll do here is write x1 plus x2 divided by x3 plus x4. And this ratio, this fraction here, has to be at least, which means greater than or equal to 1.2 to 1. And so that's going to be our fourth constraint. The last part of this problem has two constraints built into it actually. First, it says that all the money must be invested, all 100,000 of it has to be put into the 4 investments available. This means that the sum invested, so that'll be x1 plus x2 plus x3 plus x4, that sum has to equal the 100,000 that we started with. Lastly, none of the investments can be shorted. This is another way of saying that x1, x2, x3, and x4 are non-negative. Because theoretically, if we were to short a stock, this is kind of like investing a negative quantity of money, but this problem doesn't allow for that. So we just let x1, x2, x3, and x4 all be greater than or equal to 0. So putting together the objective function and constraints, we've built a simple investments model with linear programming. Using a solver like the one built into Excel, you can solve this problem and get the optimal amounts to spend in each of the 4 types of investments. Keep in mind that the objective function is giving you the expected return. It's not necessarily the case that stocks or mutual funds will always give the return rates that you see here, because they're always subject to market risk. And so because of that, you should modify or add to the constraints based on your risk tolerance level. More conservative investors or risk-averse investors will be skewed towards putting money into bonds and the savings account, because these are less risky options. Whereas the risk seekers will allocate more funds into mutual funds and stocks in hopes that they get higher return on their money.